Today we will be solving Leetcode question 42, trapping rainwater. We are given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it will trap after raining. So let's try to solve this. So whenever we are trying to solve a question, we should try to first think of the brute force approach, and then eventually we should try and optimize it. So what we could do is we could start from the first element, iterate throughout the array, and then try to find out how much water it can store. What we'll do is we'll start with the first element and we'll look left of it and find the maximum height of the bar to the left of the current index, and same thing on the right. And then what we'll do is we'll subtract the height of the current bar from the minimum of the left and right maximum that we have found. What we will do is let's try to understand with a dry run. So when we are at index 0, we'll try to find out how much water is stored here. What we will do is find out the maximum at the left and the maximum at right. So in this case there is no maximum at left, and the maximum at right will be maximum at left does not exist because it is the 0th element, so nothing. On the right it would be 3, as we can see here, so we can't do anything in this case. So and the height, so maximum will be just 0. So what we'll do is 0 minimum of these. So the minimum will be 0, 0 minus 0 will be 0, so we'll add it to the result. So it will be 0. Then we'll find water stored at this bar. We'll move the pointer to the next element. We'll go to the left. We'll see, okay, that's 0, and the maximum is 3, same. So it will be it will be 0 minus 1. If it's negative, we are just going to ignore it, so it will be just 0. We'll move to the next index. We'll try to find out how much water can be stored here. So the left max is 1, right max is 2. So minimum of these two will be 1. So 1 minus 0, which is 1, so we'll add 1. We'll move to the next index. We'll try to find out how much water is stored on this particular bar and above it. So the left max is 1, the right max is 3, minus the current height. So if it's negative, we are just going to ignore it. So it will be 1 minus 2, we are just going to ignore it. On the next element, so the left max is 2, the right max is 3. So the minimum of these two minus the current height, that is 2 minus 1, that is 1. So we'll add 1 here to the result. We'll move next element. So the left max is 2, right max is 3, minus the height of the current element, that is 0. So it will be minimum of these two. 2 minus 0 will be 2, so we'll add 2 to the result. We'll move to the next element. the height is 1, left max is 2, right max is 3, so it will be 2 minus 1, which will be 1 will be stored, so we'll add that to the result. We move to the next element, 3, left max is 2, right max is 2, so 2 minus 2, so minimum of 2 and 2 is 2, 2 minus 3 it's negative, so we'll just ignore it. So we'll just ignore it. We'll move to the next element. Left max is 3, right max is 2, so minimum of 3 and 2 is 2, minus current height 2, which is 0. We'll add nothing to the array. We come to the next element. Left max is 3, right max is 2, 2 minus 1 is 1, so we'll add 1 to the result. We'll move to the next element. So 2, left max is 3, right max is 1, so we'll take minimum of that 1 minus 2, which will be minus 1, so we'll just ignore it. We'll add nothing to the array. We'll move to the next element. Left max is 2, right max not there, so we'll just ignore it because there will be no one to store water over here, so we'll just ignore it, and the result will be 6. So as we see this is a O of n square complexity solution, because every time we are trying to traversing an element, we are also traversing the entire array again to find out the left max and the right max. So let's look at the code. So as you can see here, as I said, when the result is negative, we'll just ignore it. Here's another way how to tackle the negative part. So for each element, when we are trying to traverse, for the outer loop, we take two variables, left max and right max, and we traverse the entire array again from I till 0 and from I till the nth element, that is the last element, and each time we store the left max in a variable left max, and we take the maximum of height or left max. So if suppose the left max is 2 and the current height is 3, we'll store 3 in that, because that is the new left max, so that the result won't be negative, and that's how we will tackle it. Same thing with the right max. So at the end of the both inner loops, when we come, we'll take the minimum of left or right and subtract it from the current height. So if suppose the left max was 2, it became, and the current height is 3, so the new current height will be 3, and the minimum of 3 and 3 would be 3 minus the current height, that is 3, because 3 is the maximum element. So I'm taking that example to explain it to you. Let's try to submit it. So as we see, 319 test cases out of 322 have passed. It means that this is a valid solution, but the complexity is too high. So let's try to optimize it. What we could do is, we could find the prefix sum and suffix sum. So what we were doing in the brute force approaches, we were trying to find it every time we were encountering an element. We were trying to find the left max and the right max. What we could do is, we could store it in a separate array, and therefore we'll be reducing over time complexity from O of n square to O of n. So let's try to find the prefix sum, prefix max. So maximum here is 0, maximum of 0 and 1 is 1, maximum of 1 and 2 is 2, maximum of 0 and 1 is 1, maximum of the maximum of 1 and 0 is 1, maximum of 1 and 2 is 2, maximum of 2 and 1 is 2, maximum of 2 and 0 is 2, maximum of 2 and 1 is 2, maximum of 2 and 3 is 3, maximum of 3 and 2 is 3, maximum of 3 and 1 is 3, 3, 3. Now let's try to find the suffix sum, suffix max. So we'll start from here. So the maximum is 1, maximum of 1 and 2 is 2, maximum of 2 and 1 is 2, maximum of 2 and 2 is 2, maximum of 2 and 3 is 3, maximum of 3 and 1 is 3, maximum of 3 and 0 is 3, maximum of 3 and 1 is 3, 3 and 2 is 3, 3, 3, 3. So now we have found out the prefix sum and suffix sum. What we were doing in the brute force approaches, we were finding it always when we were encountering an element, but now we have stored it. So what we can do is very conveniently find out the difference. We will find out the minimum of these two and subtract it from the current element height, and then we can add the result. So if it is positive, we will add it to the sum, and while coding I'll show you how to tackle the negative part. So minimum of 0 and 3 minus the current height, 0 in this case, so it will be 0. The next element, minimum of 3 so for the first element, when we come here, minimum of 1 and 3 is 1, 1 minus 1 is 0, so we'll add 0 to the result, 0, 0. Then minimum of 1 and 3 is 1 minus the height of this element, we are here now, it'll be 1. Next, minimum of 2 and 3 minus the current height, that is 2 minus 2 is 0, so we'll add 0. Minimum of 3 and 2 is 2, 2 minus 1 is minimum of 2 and 3 minus the height of current element, minimum of 2 and 3 and the minus the height of the current element, that is 2, 2 minus 0 is 2, minimum of 2 and 3 minus the height of the current element, that is 2 minus 1, that is 1. Then minimum of 3 and 3 minus the height of the current element, that is 0. Minimum of 2 and 3 minus the height of the current element, that is 0. 2 is the minimum and minus 2 is 0. Minimum of 2 and 3 minus the height of the current element, that is 1. 2 minus 1 is 1. Minimum of 3 and 2 minus the height of the current element, that is 2. 2 minus 2 is 0. Minimum of 3 and 1 minus the height of the current element, that is 1. 1 minus 1 is 0. So now we'll add up the sum. So it is 0 plus 0 plus 1 plus 1 plus 2, that is 4, plus 1 is 5, plus 1 is 6. So the result is 6. So this was the optimized version. Let's try to understand the code for the optimal approach. So we'll be keeping a left max and a right max, and we'll be keeping a prefix max array and a suffix max array. We'll be iterating through the array and we'll be finding the maximum for each element. For the prefix max, we'll be starting from 0 all the way up till n, and we'll be finding which is the maximum element from 0 till the ith position. And in the suffix max, we'll be finding the maximum from the last position all the way up till the 0th position. as we have already discussed. And finally, one final time we'll be running through the entire loop, entire array once, and we'll be finding the minimum of the suffix and prefix, and we'll be subtracting that from the current height to find the result. Now let us look at the most optimized solution. So for this solution, we'll be trying to use the 2-pointer approach. We'll be keeping a left pointer, a right pointer, a left max, and a right max. So I'll try to explain you the intuition, and then we can try to look at the dry run. So initially left max and right max both will be 0, and the right pointer will be at n-1. So if you see that if the left pointer is at a height which is less than or equal to the height of the right pointer, there is a possibility that there can be water in between. And if the left pointer is less than or equal to the left max, only then there is a possibility that there will be water in between. So these are the two things that you need to keep in mind before we start. So let's start with the left pointer and the right pointer. So initially we check if left pointer is less than or equal to the right pointer, the height of the right pointer. If so, we have to check if the height of left pointer is less than the height of left max. If that is the case, then we'll add it to the result. We'll add the difference of the left max and the height of the current left pointer. If not, it means that the left pointer's height is more than the left max, so we need to update the left max. So let's try to look at it. So the left pointer is at 0, right pointer is at r-1, and once we are done with that, we need to increment the left pointer, and then we'll see how it goes. So the left pointer is 0, the right pointer is 1, so it is less than or equal to the right pointer, so we increment the, so we check if it is less than, L max is 0. Is 0 less than 0? No. So we update the left max to h of L. So this is 0 and this is 0, so it will get updated to 0. So let's keep moving forward. So now the left pointer is at 1 and the right pointer is 1. So it is less than or equal to the left pointer is less than or equal to the right pointer. So we can continue. Is the left pointer less than the left max? No. So we'll need to update it. So we'll update it. We'll go here. We'll update it. And the left max becomes 1. We'll keep incrementing the left pointer. Is 0 less than or equal to 1? Yes. So is the height of left pointer less than the left max? Left max is 1. Current height is 0. So yes. We'll be incrementing the result. So we'll add left max is 1 minus height of left pointer, that is 0. 1 minus 0 is 1. So we'll increment that. We'll increment the left pointer. The left pointer is 2. The right pointer is 1. So we'll go to the else part. The else part is very similar to the first condition. It means that the left pointer is greater than the height of the right pointer. So we'll be checking similar things as we did before. If the height of right pointer is less than the height of right max, we will increment the result. If not, it means that the right pointer is greater than the right max, so we'll update the right max. And eventually, when we are out of both of these conditions, one of them will be executed. We need to decrement. So we'll decrement the right pointer and we'll continue. So in this case, 3 was greater than 1, so we checked if the height of right max is greater than the height of the current right pointer. It is 0, so no, 1 is greater than 0, so we update the right max and then we reduce the right counter. So the right counter is set, right pointer is at 2. Is 2 less than or equal to 2? Yes, so we'll go in the if condition. If the height of left pointer is less than the height of left max, no, so we'll update the left max, so the left max becomes 2, and then we increment the left pointer. Now we check, is the height of left pointer less than or equal to the height of right pointer? The right pointer is 2, left pointer is 1, so we go in the if condition. If the height of left pointer less than the left max is 2, current left pointer is at 1, so we'll add the result. So left max is 2 minus the height of the current one, that is 1, left pointer, and then it becomes 1, so we'll add it to the result, becomes 1 plus 1, 2. Okay, we increment the left pointer, we go at 0, height is 0 now. Is it less than 0 is less than 2, the right pointer? We go in the if condition. Height of the current pointer, left pointer is less than the left max, so we increment the result, that is 2 minus 0. 2 is the left max, 0 is the current pointer, left pointer, so it will be 2. We increment 2, we increment the left pointer, so 1 is less than 2, so we go in the if condition. 1 is less than the left max, so we increment it again, so it is 2 minus the height of current left pointer, L max minus the height of current left pointer, that is 1, so we increment 1, we increment the left pointer, goes, now it's 3. 3 is not less than or equal to 2, so height of left pointer not less than the height of right pointer, so we go in the else condition. The height of right pointer is it less than the right max? The right is 2, right max is also 2, so no, it'll go in the, so it'll update it to 2 again, and it'll reduce the right pointer, so the right pointer comes to 1, right max is 2 now, and then we compare again. If the height of the left pointer is less than or equal to the height of right pointer? No, so we go into the else condition. In the else condition, we see the height of right is 1. Is it less than the height of right max? That is 2. Yes, so we increment the water, so right max is 2 minus the height of current right pointer, that is 1, which is equal to 1, so we increment it to the right pointer 1. Then we reduce the right pointer, it comes to 2, the right max is 2, the current, so we check, is the height of left pointer less than the height of right pointer? No, we go to the else condition. If the height of right pointer less than the height of right max? No, so we go in the else condition, we update to 2 again, and then we reduce the right pointer. So the right pointer goes here where the left pointer is currently, and we see, is the height of left pointer less than or equal to the right pointer? Yes. Is the height of left max less than the height of L max? L max is 3, Lmax is 2 currently. So we go to the else condition, we update 3, and then we move the left pointer forward. So now the left pointer and the right pointer have crossed, so we need to stop the loop. So let's look at the code now. So this is so let's look at the code now. So we have 2 pointers, left pointer and right pointer, and we have the result. So there's a left max and there's a right max. We initialize it to int min, while left is less than or equal to right pointer. If the height of left is less than or equal to right, we go and we check if the height of the left pointer is less than the left max. We add it to the result. If not, we update the left max and then we increment the left pointer. If the first condition, that the left pointer is not less than or equal to the height of right pointer, we go to the else condition. We check similar things. If the height of right is less than the height of right max, if so, we increment the result. If not, we update the right max and then we decrement the right pointer, and finally we return the result. Let's try and submit this. So the test cases have run successfully. Let's try to submit it. So this works, this solution works. I hope you liked this video. If you did learn something from it, do like, share and subscribe.